Hello class, in this lesson, let's get to know power cable lines. First, let's watch a video. Follow He Guanhua, winner of the National May 1st Labor Medal. We'll take a tour of the cable tunnel together.
Follow He Guanhua to tour the cable tunnel. Xinhua News Agency reporter Chen Si. Hongqi Substation Tunnel, Wuxi, Jiangsu. He Guanhua, Director of Cable Operation and Inspection Center of State-Grade Wuxi Power Supply Company. The cable tunnel is actually a well-connected network, equivalent to a condition similar to a cable rail. We used to have to rely on people. Go to each channel. Let's go one by one, check one by one monitoring, inspection. Such an efficiency, relatively low. For our personnel, the work pressure is also quite high. Now we are using our smart robots to perform inspection work. The independently developed soft rope robot led by He Guanhua can switch freely between different tracks. Flexible adaptation to the complex and limited spatial environment of underground tunnels. Realize intelligent video, infrared imaging, tunnel micrometeorology, gas detection, defect recognition, and alarm functions. Intelligent perception network composed of IoT sensing devices. Real-time monitoring of temperature, humidity, toxic and harmful gases inside the tunnel, and information such as current and voltage of the cable body, fault location, etc., through the cable tunnel intelligent monitoring system. Synchronized transmission to the monitoring screen of the cable inspection center. Technicians can remotely and comprehensively perceive the operating environment of cable tunnels. In this smart tunnel, there's still a research achievement that has won the second prize of National Science and Technology Progress Award hidden deep inside. Large cross-section cable. It's like a snake, not rigid, but in fact, every meter of it weighs 38 kilograms, very heavy. So this place has also applied one of the overall construction technology that won the national award. This is what happened. A laying method with high drop and long sections. We can see the words inside here. It is actually very rigid. We need to do this kind of bending. The purpose is that our cables will experience significant thermal stress. Through such a serpentine layout, can release thermal stress so as to ensure that our cables can operate safely. He Guanhua, Director of Cable Operation and Inspection Center of State-Grade Wuxi Power Supply Company. High drop, high voltage, cable body, non-destructive bending and fixing technology. It was developed by He Guanhua's team after 8 years of research and development. One of the achievements in the construction series of high drop, high voltage cables. This series of achievements starts from the construction process of cable laying. Eliminate safety hazards during later cable operation. Solved the rapid development of urban three-dimensional transportation and underground pipelines. The several character, shape, and height differences brought about difficulties in cable engineering with narrow space and multiple vibration sources characteristics. The current series of scientific research achievements have been applied to cable construction projects in 28 provinces and cities across the country. and promoted to industries such as railways, communications, petrochemicals, steel, etc. And countries such as Germany, Sweden, Singapore, Saudi Arabia, etc., achieved economic benefits of 750 million yuan in the past 3 years. In similarly ordinary cable tunnels, creative achievements of Chinese individual workers in the new era, adding a sense of intelligence to the safe operation of urban power arteries. Stripping copper shielding layer and outer semiconducting layer.
Through this video, you have a preliminary impression of. So what does a power cable line consist of? The internal structure of power cables. What is the internal structure of power cables? This lesson is mainly about contents. A power cable overview. Second, the structure of power cables. Power cables are widely used in various sectors of the national economy for the industry, defense construction, and major construction projects to provide important supporting. In compared to the national economy of the blood vessels and nerves, is the modern economy and social functioning of the basic security. Next, look at the power cable line. Composition diagram. As shown in the figure below, power cable line composition for the power cable body, cable accessories, cable structures. Power cable body is used for power transmission and distribution of high-power electrical energy. Cable accessories mainly include cable terminals, cable connectors. Cable termination refers to the installation at the end of the cable to connect the cable to other electrical equipment or overhead transmission and distribution lines, and maintains installation up to the point of connection. Power terminals are shown on the left. The end of a cable line, the part that connects to the overhead line. Power terminal on the right, shown on the right, the part that connects to the ring network cabinet. Cable joints are also known as intermediate joints, refers to the connection of a cable with the conductors of the cable insulation, shielding and protection to make the cable line continuous, as shown in the figure. The part of the cable that connects to the cable lead is an intermediate connector. It is thicker than the cable body. Cable structure is the part used to support and install the cable and its accessories, including cable poles, cable tunnels, trenches, etc. This is cable trench lay. Power cables are laid on supports in cable trenches. The diagram above shows direct burial. The cable is buried directly in the soil. The next two are tunneling and bridge laying. Advantages and disadvantages of cable routes compared to overhead lines. Advantages: occupies less ground and space, safe and reliable power supply, has possibility of electric shock, favorable to improve the power factor of the system. Operation and maintenance work is simple and convenient. It is good for beautifying the city and has confidentiality. Disadvantages: large one-time investment costs. It's not easy to change. Line not easy to branch. 4. Difficult to detect faults and long repair time. The production process of cable gland accessories requires high technology and costs. According to the insulation material, oil paper insulated cable, oil impregnated paper as the insulating media. It is called oil impregnated paper insulated, extruded insulated cable. All kinds of rubber, plastic by extrusion molding cable, also known as rubber plastic cables, PVC, including polyvinyl chloride PVC cable, P, polyethylene P cable, XLPE, cross-like sending polyethylene, XLPE cable, IRP, and ethylene propylene rubbery RP cable, pressure cables, including self-capacitating oil-filled cables, steel pipe inflatable cables, according to the transmission voltage, AC cable. Currently talking about all AC cables. DC cable. DC cable. Different electric field distribution with AC cable cannot be interchanged. According to the number of conductor, cores can be divided into single core, 2 core, 3 core, 4 core, 5 and 5 core, a total of 5 kinds, as shown in the figure. Take the lower right cable as an example. The golden colored part in the middle is the copper core. It is used to transmit electricity. The whole cable is only one bundle of copper cores, so it is a single core cable. To the left is a 3-core cable, are 3 bundles of gold-colored copper cores. To the right of the 3-core cable is the 5-core cable. To the left of the 5-core cable is a 4-core cable. Next, let's talk about the second part, the composition of the power cable structure. First, we watch a video, have a preliminary understanding of the structure of the cable.
Straighten the cable end, saw it all together, and overlap the 2 cables to be connected by about 400 millimeters in length. Clean the outer pole surface of the cable. Then peel off one of them with a 1000 millimeters long outer sheath. Peel off another 800 millimeters long outer sheath. Use a steel saw to roughen the area below. The outer sheath port by 100 to 120 millimeter. Measure 30 millimeters upwards from the outer sheath port. Peel off the armor above. Leave a 50 millimeter long inner sheath upward from the armor. Peel off the rest. Roughen the inner sheath. Remove the cable lining material, such as armor. Then remove the steps related to it afterwards. Seal the 3-phase armor. Try to bend each phase in approximately 15 times the size of the cable box from the windward direction. Make each phase in a docking state. The distance between phases is about 55 millimeters. Saw the center of each relative connection. Keep it 740 millimeters away from the inner sheath port of the longer end cable, 540 millimeters away from the inner sheath port of the outer end of the cable. Remove excess cables from each phase. The cutting point of each phase cable is the end of the cable. Strip in copper shielding layer and outer semiconducting layer. Strip a 220 millimeters long copper shield downwards from the end of the cable, and at the copper shielding end, stick PVC tape to 8 microns. Measure 157 millimeters from each end of the 2 cables. Mark with PVC tape. Peel off the 157 millimeter long outer semiconducting layer. When peeling, it is required to have a neat cross-section, and it is not allowed to scratch the insulation layer. Remove the PVC tape markings on the outer semiconductor layer. Make the port a small slope to smoothly transition with the insulation layer. No pits, steps, or knife marks are allowed. When processing the convex ribs, they must be polished and removed to ensure the outer semiconductor layer of the cable. Round and smooth. Process the other 2 phases according to this process. Third, peel off the insulation layer and sleeve the insulation body of the joint. Measure the length of the cable connecting tube L. Then peel off the insulation layer and the inner and outer surface layers by half the length of L. Then remove the sharp corners of the insulation end. Note, the stripping should not be too long and the insulation end should not be cut into a cone shape. Then use sandpaper to polish the surface of the insulation layer. Clear adhesion of the photovoltaic powder layer on the surface of the insulation layer. Require a smooth surface of the insulation layer after polishing. Visible scratches and defects are not allowed. Apply a semiconductive layer on the surface of the cable insulation layer. Clean the copper shielding layer with a cleaning cloth.
In the video, our structure consists of what is the role of each component? Let's look at this picture. 10 kV. Take a 10 kV cross-linked power cable for example. We from the inside to the outside of the power cable. Separate introduction to see the composition and role of the cable structure. First of all, look at the 3 golden colored bundles. This is the core conductor. ABC. This refers to the ABC phase. Her function is to conduct electricity and transmit it. The black part of the core surrounded by a layer outside is the inner semiconducting layer. An inner semiconductive layer is made of semiconductive material. Its function is to even out the surface potential of the core. It prevents electrical discharges between the core and the insulator. Discharge will erode the insulation, destroy the insulator. At the same time, the inner semiconducting layer and insulation layer closely combine with the transition, avoids gaps and discharges. Outside the inner semiconductive layer is an insulating layer. Its function is to insulate. The reason why we touch the surface of the cable without being electrocuted, because the electricity has its own insulation to protect the human body from electric shock. Outside the insulating layer is the outer semiconductive layer. The function of the outer semiconductive layer is to eliminate the gap between the copper shield and the insulation layer to avoid electrical discharges. If there is no outer semiconductive copper shield and the insulating layer would discharge, which destroys the insulation from the outside in. Outside the insulation is the copper shield. The copper shield is grounded, acts as a shield against electric fields, and conducts the fault current. Shielding electric field is to shield the electric field generated by the core of the wire, prevents interference with the outside world. Fault current conduction. It is when the defects such as aging of the insulation are broken down. Single-phase grounding current flows to earth through the grounded copper shielding layer, thus protecting personal safety. Outside the copper shield is a filler to fill the gap. Outside the filler is the inner sheath. The inner jacket acts as a sealing protection, protecting the insulation from moisture. It protects the insulation from mechanical damage or chemical attack. Outside the inner sheath is the armor, enhances mechanical protection. Outside the armor is the outer sheath, prevents the insulation from coming into contact with moisture or other substances, prevents some mechanical damage. An inner and outer sheaths are equivalent to a double layer of protection. After recognizing the structure and function of 3 core turnkey cables, then the structure and role of single core cable is clearer. Single core cable by the core conductor, inner semiconductive layer, outer semiconductive layer, insulation layer, outer semiconductive layer, copper shielding layer and a sheath, armor outer sheath. 10 The role of each part and 10 kV cable the same. This lesson mainly talks about the concept of power cable and cable body structure, composition and role. This is the end of the course. Thank you.